Greetings everyone, dear ICEST 2020 participants. I'm Nenad Petrović, a teaching assistant at the Faculty of Electronic Engineering, University of Niš in Serbia, the Department of Computer Science. In what follows, I will present you my paper entitled Tackling the COVID-19 Conspiracies, the Data-Driven Approach. As we are all introduced, the recent COVID-19 pandemic has taken a huge number of lives on one side and had dramatic impact on economy, business and production on the other side. As a side effect, several conspiracy theories have emerged as a result, especially with social networks. One of them is the correlation between 5G users increase and COVID-19 cases. So even an organized group of people as a consequence attacked 5G towers, causing serious damage to telco operators. So in pandemic situation, it is really necessary to distinguish between conspiracies and true facts about the disease itself in order to reduce the overall damage caused to humanity. So the research goal of this paper is actually to propose a data-driven framework that will be able to discover conspiracies among the publicly available online texts, both scientific and non-scientific, and on the other side, public data sets. As a solution, I proposed a combination of fuzzy reasoning performed on semantic representation of these texts on one side and correlation analysis performed within the public data sets on the other side. So let's see what is behind the proposed framework. Semantic knowledge representation. The central concept here is ontology. In computer science, it is used for conceptualization of a knowledge from a particular domain. Here we have classes and actually which represent relevant entities and aspects of some domain. Also, we have instances of these classes. They both have properties which are called attributes. We can also establish relationships between these concepts. So, moreover, we have RDF standard that is used for representation for both ontologies and semantic knowledge bases. And on the other side, we have Spark query language that is used to test asserts whether they hold within the semantic knowledge base and retrieve the necessary data from semantic knowledge bases. The semantic knowledge base consists of triplets in a form of subject, predicate, and object. There are several notable use cases related to pandemics when it comes to ontologies. The first one is actually used for in past bird influenza around a decade ago for simulation of pandemic scenario. Another one is epidemiology ontology that is used to enable sharing of epidemiology-related resources within semantic-enabled platforms. And the third one is extension of the previous work that enables to tackle the recent COVID-19 pandemic. In this paper, I adopt ontology learning in order to represent publicly available text in a semantic form. I rely on my previous work that had been presented in the shown paper that uses Stanford Core NLP library with natural language processing capabilities in order to construct triplets from text given as input. Fuzzy logic is a form of multi-valued logic where apart from 0 and 1, we can have any real number value from that range. It's adopted in many systems where complex and uncertain reasoning process is needed that is close to human expertise. In this paper, it is used to tackle the partial truth or null facts about COVID-19 disease which are available online. Notable use cases examples come from medical and clinical healthcare application decisioning systems. When it comes to correlation analysis, it's a statistical method which is used for discovery of a relationship between two variables and strength of the relationship. It can have any value from -1 to +1, where the negative values mean that increase of one variable will cause the decrease of another one and vice versa, while the positive value means that increase of one variable will also increase another one. Notable use case examples related to COVID-19 pandemics are the following. First one is the analysis of correlation between confirmed cases of COVID-19 in Spain and several geographic, meteorological, and socio-economic variables. On the other side, we have correlation between racial demographics and COVID-19 cases in US. In this paper, I use MATLAB implementation of Pearson's correlation coefficient, which is widely used in order to calculate the correlation between variables that are taken from public online data sets. Now let's see the implementation of my framework. First, we have users that define actually the hypothesis they want to test. There are two possible forms. The first one is condition set implies consequence. Another one is a relation, binary relation between two concepts. After that, once the user provides the desired hypothesis, it is forwarded to search and retrieval module. It takes the key terms from the hypothesis in order to find relevant scientific texts and public data sets. After that, the correlation analysis is performed against the dataset, while ontology learning is performed against the retrieved texts and scientific literature. It is stored in semantic knowledge base. After that, once we have correlation coefficients and once we perform the ontology learning, we can add the truth factor for each of these facts. So it consists of two formulas. The first one is fact truth that is calculated as a ratio between the number of texts that say that some relation between two concepts exists and the overall number of texts that consist these key terms extracted from hypothesis. And on the other side, correlation coefficient between these two concepts taken as a result of correlation analysis from the data sets on the other side. And the source trust is actually how much some online source is trustworthy, is calculated, for example, for scientific literature as an impact factor of that publication. So here in short words, I will formally represent the conspiracy testing method. As input, we have user-provided hypothesis and conspiracy threshold, which actually means that if facts truth value is below that one, it means that we are talking about conspiracy. Otherwise, we have some fact that is true. The output is true or false, meaning whether the test hypothesis is true or false. So now let's see how it works. First, the key terms are extracted from hypothesis, and for each term t in set of key terms, we retrieve the relevant texts about that term t. They are transformed in semantic form using ontology learning module and added to semantic knowledge base. Moreover, the relevant dataset are extracted from online sources and correlation coefficient is calculated. Finally, the overall truth of these facts is calculated using the previously shown formulas. Finally, after that, we have testing whether something is conspiracy or not. For each of the facts, it is taken, the truth value is taken, the previously calculated truth value is taken and compared against the threshold. In my case, I used 0.8 threshold. Actually, it means that if something is below 80% truth, means that it is false. So for each of the facts, we test the truth value, and if it's below the threshold for at least one of them, it means that we're talking about a conspiracy. Now let's see evaluation and results. The evaluation was performed on a shown laptop configuration. PubMed papers were taken as a basis for text corpus, and these two websites for public data sets. Now let's see the table of the experiments. The first column shows the hypothesis that is about to be tested. The first hypothesis was whether the increase of 5G users also increases the number of COVID-19 cases. The second one is whether the age increases death rate, and also whether if someone is chronic patient has effect on a death rate when it comes to COVID-19. The second column shows the number of texts that were used for ontology learning. The third column is the number of seconds used for construction of a semantic representation of a text corpus. As you can see, it's the longest time here, about a few minutes. The fourth column is correlation coefficient calculation time, which is like just 1/10 of a second in the first case and 1/4 of a second in the second case. And the fifth is reasoning time that is used for overall process executing Spark queries and taking into account the correlation coefficient and the previously shown formulas in order to determine whether something is true or not. And the final column says whether the fact was true or false. As you can see, the first one, which is obviously a conspiracy, had given output false, while the other two actually given value true, which is also known in the existing publications, medical publications. Let's conclude. The presented approach has huge potential for adoption within various systems and use cases. In future, I plan to integrate it within some medical decisioning process applications. Finally, I would like to have included the presented solution within my framework, which is another work that I'm working on currently for efficient resource planning in pandemic crisis with goal of patient risk assessment, and I want to leverage it, have all that within a mobile app. As you can see, there are two screenshots of a mobile app I'm working on that will be published soon. Thank you for your attention. This work has been supported by the Ministry of Education, Science and Technological Development of the Republic of Serbia.